Why do we spend so much time looking for life on Mars when the red planet has had liquid water for only 400 million years? While here, 2 steps, there is Venus that has hosted oceans for 3 billion years and no one considers it. Do you think we overlooked a little too much the planet that before the space age was still considered fit for life and perhaps covered by oceans? Since then, for example, NASA has sent 10 orbiters and 10 landers or rovers to Mars, but just 2 orbiters to Venus and none since 1994. This has not been for lack of scientific interest. Since the mid-1990s, U.S. scientists alone have submitted nearly 30 Venus proposals to NASA. None have been approved. It was during the space race that scientists discovered on Venus a torrid and toxic world. That could explain why interest in Venus dwindled. Scientists quickly realized that this planet would not be a home for future human exploration, nor an outlet on which to search for life. It would be downright difficult to study at all, even for short amounts of time. But the wind is changing, which was due to the controversial finding of phosphine in its atmosphere. Lately, the interest in the twin sister of Earth has been increasing, and NASA has finally approved new exploratory missions. More and more planetologists are hypothesizing for Venus the possibility of terraforming, even more than Mars. Hard to believe? Well, keep watching. Let's figure it out. Terraforming Venus quickly? Fascinating, but impossible for at least 1,000 years. Like Mars, Venus was once a vastly different place. According to data gathered by various missions, it is believed that until 700 million years ago, Venus was a warm and wet planet where oceans covered 80% of the surface. This is actually close to what scientists thought Venus was like until the Soviet Venera and NASA Mariner probes revealed what a hellish place it is today. This came to an end apparently due to a near-global resurfacing event that occurred 500 million years ago, where large amounts of magma bubbled up from the mantle and released massive amounts of CO2 into the atmosphere. This magma would have solidified before reaching the surface and created a barrier preventing the atmospheric CO2 from being reabsorbed by the crust. What followed was a runaway greenhouse effect that caused severe climate change, leading to the hostile environment that we see there today. However, if the planet could be restored to its former self, by reversing the greenhouse effect, which is possible, then humanity would have a planet closer to Earth that is roughly equal in size, mass, and gravity. Let's compare. Venus is the closest planet to Earth, ranging from a minimum distance of about 38.2 million kilometers to a maximum of around 261 million kilometers. Because of the nature of our orbits, Earth and Venus make their closest approach every 584 days, 1 year and 7 months, which is known as an inferior conjunction. In contrast, the average distance between Earth and Mars is about 225 million kilometers, ranging from 55.7 million kilometers to 401.3 million kilometers. Our 2 planets make their closest approach every 26 months, 2 years and 2 months, which is known as an opposition, since the Sun and Mars are on opposite sides of the sky when viewed from Earth. So not only does Venus get closer to Earth than Mars, but it also makes its closest approach to us more often. This means that missions to Venus could launch more often and would take less time to get there. Then there's the matter of Venus's gravity, which is the equivalent of 90% to what we experience here on Earth. Compare this to Mars, where the gravity is roughly 38% of Earth's. This means that for potential settlers, the health-related risks associated with lower gravity would be much lower. Of course, Venus, as it is today, has its share of challenges that makes the prospect of living there very difficult. These make terraforming not only a good idea, but a potential necessity, assuming people want to live there in large numbers. Otherwise, they will need to be happy living in floating cities among the clouds, an actual possibility. For starters, Venus is the hottest planet in the solar system, with an average surface temperature of 464 degrees Celsius, which is hot enough to melt metals like lead and zinc. The atmosphere is also a toxic fume, composed overwhelmingly of carbon dioxide, with trace amounts of nitrogen, sulfur dioxide, and water vapor. However, unlike Mars, atmospheric pressure on Venus is 90 times the pressure of Earth's atmosphere. To experience that kind of pressure here on Earth, a person would have to venture over 910 meters under the sea. So unless you have a vehicle that can withstand extreme heat and pressure, you're not getting anywhere near the surface. As if that weren't enough, Venus's atmosphere is also permeated by clouds of sulfuric acid rain. These have been observed in Venus's upper atmosphere and may not condense closer to the surface, but spacecraft attempting to land on the surface must first penetrate this acidic shroud. Venus also has the slowest rotation period of any major planet, taking roughly 243 Earth days to rotate once on its axis. On top of that, Venus rotates in the opposite direction as the Sun, retrograde rotation, which is something astronomers have only ever observed with one other planet, Uranus. Between its slow retrograde rotation and the fact that Venus takes close to 225 days to orbit the Sun, a single solar day on Venus lasts 116.75 days. This means that for an observer on the surface of Venus, it takes close to 4 months for the Sun to set and rise again, compared to 24 hours here on Earth. Venus is also isothermal, which means that it experiences virtually no variation in temperature. This is due to its dense atmosphere, but also its slow rotation and its low axial tilt, 3 degrees versus Earth's 23.5 degrees, which essentially means that Venus doesn't experience seasons or anything we might consider a day-night cycle. If you're thinking that this is starting to sound like something out of Dante's Inferno, then you're on the right track. But with the right kind of work, it could be made into something more akin to a tropical island paradise. Hang on a sec before we continue. Be sure to join the Insane Curiosity channel. Click on the bell. You will help us to make products of even higher quality. Luckily, with the right kind of ecological techniques and some serious elbow grease, Venus could be terraformed into an ocean planet with mild temperatures and endless beachfront property. As with Mars, it comes down to 3 major goals. They include reducing the atmospheric pressure, lowering the temperature, converting the atmosphere to something breathable. Much like terraforming Mars, these 3 goals are complementary, even if they are the complete opposite. Luckily for us, Venus has a lot to work with, and the outcome would be easier for humans to adapt to. The first proposed method was made by none other than Carl Sagan in 1961 in a paper titled The Planet Venus. It was in this paper that Sagan argued that seeding the atmosphere of Venus with genetically engineered cyanobacteria could gradually convert atmospheric carbon dioxide to organic molecules. Unfortunately, the subsequent discovery of sulfuric acid clouds and the effects of solar wind made this proposal impractical. It would be another 30 years before another proposal for terraforming Venus was made, which was done by Paul Birch in his 1991 paper, Terraforming Venus Quickly. According to Birch, flooding Venus's atmosphere with hydrogen would trigger a chemical reaction, creating graphite and water. The graphite would be sequestered while the water would fall as rain and cover 80% of the surface in oceans. Another proposal is to use solar shades, something that was recommended by Birch and famed aerospace engineer and space exploration advocate Robert Zubrin. This concept would involve using a series of small reflective spacecraft in Venus's atmosphere to divert sunlight, thereby reducing global temperatures. Alternately, a single large shade could be positioned at the Sun-Venus L1 Lagrangian point to limit the amount of sunlight reaching Venus. This shade would also block solar wind, preventing Venus's atmosphere from being stripped and also shielding the planet from solar radiation. This would trigger global cooling, resulting in the liquefaction or freezing of atmospheric CO2, which would then be deposited on the surface as dry ice, which could be shipped off-world or sequestered underground. Another suggestion is to speed up Venus's rotation, which could have the added benefit of generating a planetary magnetic field. There are a number of ways to do this, like striking Venus's surface with large asteroids or using mass drivers or dynamic compression members to impart transfer energy and momentum to the surface. This would allow for the creation of an Earth-like diurnal cycle and could also help remove some of Venus's dense atmosphere. Similarly, mass drivers or space elevators could scoop clouds from Venus's atmosphere and eject them into space, gradually thinning it out over time. The end result of this would be a Venus very much like its former self. This would mean a planet covered predominantly by oceans. Due to the nature of Venus's geological features and small variations in elevation, the surface would essentially be a giant archipelago with a few larger continents. Over time, humans could introduce terrestrial organisms like plants, trees, bacteria, and aquatic species to Venus. With some modifications, this could lead to an explosion of life and the development of a tropical planet with biodiverse jungles on the larger landmasses and more coastline than you can shake a stick at. Okay, you may have already figured out what the downside of all of this is. If you guessed that it would take a massive effort to transform Venus, and it would be very challenging to create a settlement there in the meantime, you'd be absolutely right. While Venus could be terraformed to become what it once was, the commitment in time, energy, and resources would be nothing short of Herculean. Beyond the similarities Venus has with Earth in size, mass, and composition, there are numerous differences that would make terraforming and colonizing it a major challenge. For one, reducing the heat and pressure of Venus's atmosphere would require a tremendous amount of energy and resources. It would also require infrastructure that does not yet exist and would be very expensive to build. For instance, it would require immense amounts of metal and advanced materials to build an orbital shade large enough to cool Venus's atmosphere to the point that its greenhouse effect would be arrested. Such a structure, if positioned at L1, would also need to be 4 times the diameter of Venus itself. It would have to be assembled in space, which would require a massive fleet of robot assemblers. In contrast, increasing the speed of Venus's rotation would require tremendous energy, not to mention a significant number of impactors that would have to come from the outer solar system, mainly from the Kuiper Belt. In all of these cases, a large fleet of spaceships would be needed to haul the necessary material, and they would need to be equipped with advanced drive systems that could make the trip in a reasonable amount of time. Currently, no such drive systems exist, and conventional methods, ranging from ion engines to chemical propellants, are neither fast nor economical enough. To illustrate, NASA's New Horizons mission took more than 11 years to make its historic rendezvous with Pluto and the Kuiper Belt, using conventional rockets and the gravity assist method. Meanwhile, the Dawn mission, which relied on ionic propulsion, took almost 4 years to reach Vesta in the asteroid belt. Neither method is practical for making repeated trips to the Kuiper Belt and hauling back icy comets and asteroids, and humanity has nowhere near the number of ships we would need to do this. The same problem of resources holds true for the concept of placing solar reflectors above the clouds. The amount of material would have to be large and would have to remain in place long after the atmosphere had been modified, since Venus's surface is currently completely enshrouded by clouds. Also, Venus already has highly reflective clouds, so any approach would have to significantly surpass its current albedo. That on a scale from 0 to 1 is worth 0.65 to make a difference. And when it comes to removing Venus's atmosphere, things are equally challenging. In 1994, James Pollock and Carl Sagan conducted calculations that indicated that an impactor measuring 700 kilometers in diameter striking Venus at high velocity would result in less than 1,000th of the total atmosphere. What's more, there would be diminishing returns as the atmosphere's density decreases, which means thousands of giant impactors would be needed. In addition, most of the ejected atmosphere would go into solar orbit near Venus, and without further intervention could be captured by Venus's gravitational field and become part of the atmosphere once again. Removing atmospheric gas using space elevators would be difficult because the planet's geostationary orbit lies an impractical distance above the surface, where removing using mass accelerators would be time-consuming and very expensive. In the end, the potential benefits of terraforming Venus are clear. Humanity would have a second home. We would be able to add its resources to our own, and we would learn valuable techniques that could help prevent cataclysmic change here on Earth. However, getting to the point where those benefits could be realized is the hard part. Like most proposed terraforming ventures, many obstacles need to be addressed beforehand. Foremost among these are transportation and logistics, mobilizing a massive fleet of robot workers and hauling craft to harness the necessary resources. After that, a multi-generational commitment would need to be made, providing financial resources to see the job through to completion. Not an easy task under the most ideal of conditions. Suffice it to say, this is something that humanity cannot do in the short run. However, looking to the future, the idea of Venus becoming our sister planet in every way imaginable, with oceans, arable land, wildlife, and cities, certainly seems like a beautiful and feasible goal. The only question is, how long will we have to wait?